This is the final section of the standard.io.h header of the standard library, and we're going to start out talking about direct input and output. Direct input and output allow us to write straight from a buffer a number of objects out to a open file pointer. And fwrite, we'll see here in just a second, reads the data back in. Now these set an feof for end of file and an ferror flag to determine if there's problems, or if we're in fact at the end of file if we're doing reading. Okay, feof and ferror, we'll see them at the end of this video. So here's fread. This is the buffer that we have to provide that has space in it for the information coming into us. The size value is the size of an individual object that we will be reading. The number is how many of those objects we will be reading, and then the file pointer is where to read from, the file pointer to read from. How many objects, how big is each object, where do we put them all when we get them from the file pointer, and the call is called fread. The number of objects that are read is what will be returned. So we can see if this matches this. If it does not, it means it will usually be less. And that means that we hit the end of file at some point. If we asked for 10 records and we only got 6, there just weren't 10 to give us. And then we can check feof and see, is that in fact what happened? And if there's an error, what was the error? Fwrite will write from our buffer a size object and how many of them to this file pointer. And it will return back to us how many were written. That should be the same that we asked for on an fwrite. Of course, the disk could have been full or something like that, and then we have to check ferror. We won't get end of file on an fwrite, but we could get ferror set on an fwrite. Okay, fread and fwrite, direct input and output. Here we're going to look at file positioning, how we in the standard library position ourselves in a file that we have opened. Files can be huge, and you can't get the whole thing into memory at once, most likely, so you have to have a way of moving yourself around the file. This is how we do it. The offset that we see here is a long type, because files could be very large, so that is much larger than an integer, and we saw that way back in the beginning, just how big of a number we can have it long. So offset has to be a long. This origin value, you remember seeing this from our seeks that we had earlier when we talked about file handling. This is seek set is from the beginning. Seek current is from the current file position, and seek end is from the end of the file backwards. Fseek, here's the file pointer, the long offset value, and the origin. So that sets our position based on the origin, the seek set current or end, and the offset of this file pointer. If we lose track, or we've done a bunch of manipulation and worked our way back and forth through the file, we may want to find out where we are in the file. We use ftell for that. Ftell of the file pointer will return the position, the current location on the file, and we can use that to start reading again, or reset, do an fseek that we want to go forward and back a number of records and so on. Rewind is the same as doing an fseek 00s back to the beginning and then doing a clear of any kind of errors so that it refreshes the whole file pointer setup, does a rewind. fgetPosition is used with fsetPosition to get a special pointer value. This is the address of a file position pointer, and the number, basically the offset of where we are on this file, will be put into pointer. You can then adjust that pointer, increment it, decrement it, do whatever you need to do with it, and then do an fsetPosition, and that will move your file pointer position to wherever you need it to be after adjusting pointer. Here's the error functions, and we have clear error on a file pointer. We'll clear the last ferror after we've taken care of the problem. Here we can get the a test of end of file, feof. So if there is and if we have hit end of file, I should say, if we have hit the end of file on the file pointer, this will return non-zero or true. If we are not yet at end of file, that will be false. So we can say if feof of a file pointer. Errors, if there are any, and there will be some, we can use ferror on a file pointer and get the current error number. Find out what it is. It should be non-zero if there's an error. And then we can print an error, a user-defined message, and we can provide a buffer to our own message. This would be a string pointer, and we can say, oops, really sorry, we had a message, and then p error will continue on and print the text that is from the operating system based on this F-error problem. So once we find that we have an error, we can use P-error to tell the customer, the client, that we've had some problems. All right, so that's the end of standardio.h. All of those things are wrapped up in standardio.h, in the standard library and the standard input and output header. There's quite a lot in there, and that's what really makes C useful, is this standard library. And remember, these things will be created, they have to be, for it to be a standard C compiler, and they'll be available to you on your implementation. They'll work a little differently because you are on whatever kind of computer and operating system you're on, but that's the whole idea of portability. The names are still the same, even though the functions could be different underneath. So let's move on to some other parts of the standard library that are not dealing with input and output.